Hi everyone, so today we're going to be trying out some physics problems using tension forces. So the first one we're going to start off with is where first we have the force of a string 1, and then which is attached to a 5 kilogram box. And then we also have another force on this acting upon this box, which is the force of string 2, which is 30 degrees to the horizontal. So what we want to try to find, what they're asking us to find, is first is the force of string 1 and the force of string 2. So that's our main objective for this problem. So the first thing we should always do with any physics problem really that involves forces is first create a basic force diagram. So first we have the force of the earth, which is the downward force of gravity, which we know is equal to mg, the mass times the downward force of gravity, which is 5 times 10, which is 15 newtons. Then we know that there's the force of string 1, and then we also have a force of string 2, which is 30 degrees, as we said earlier. So then what we want to do now is is dissect this into. So now what we want to do is dissect this force diagram into XY forces, so that we can look at this problem and actually solve it. Because right now given this basic information, we can't really go anywhere. So we're going to try to create another force diagram and create and add XY forces so we can try to solve this. So then again we have the force of the earth, which is 50 newtons. And then we have the force of string 1. And then, so now what we're going to do is dissect the force of string 2 into XY forces. So we have the force of string 2y, and the force of string 2x. And then using this information, we can now create a triangle. So that means we have the force of string 2. So we're creating this triangle, just to point out, is we're creating this triangle using our first force diagram with the angle and the actual force of string 2, and then we also have another force diagram with the force of string 2 dissected into xy forces. So now we're creating a triangle using those forces. So we have the force of string 2, and then we have the upwards force of string 2y, and then we have the horizontal force of the force of string 2x. We know that this is equal to 30 degrees. So from here, so one thing you want to point out is that because this object is suspended in motion, it's at rest in the air, obviously. That means that the force of string 2 y, this force is equal to the force of the earth. So that means, so if if force of string 2y is equal to the force of earth, that means equal to 50 newtons. So we're going to use this to solve for some values later on. So now what we're going to do is use basic trigonometric properties to calculate some forces. So we can say that the sine of 30 degrees is equal to the force of string 2 y over the force of string 2. And we know this because we know that the sine identity is the opposite side over the hypotenuse. So that's what we did over here, opposite hypotenuse. So, and then after that we can plug in a number. So that tells us that the force of string 2 is equal to the force of string fs2y over sine 30, which is equal to 50 over the sine of 30 degrees. So that's equal to 100 newtons. So we can just put that in here. And then we know and then we know that we deduced that the force of string 2y is equal to the force of Earth because the object is suspended in motion. It's at rest, hanging in the air. Using the same idea, we can say that the force of string 1 is equal to the force of string 2x because we've already stated that this object is suspended in motion. It's not going anywhere. It's just hanging in the air. So using this, we can say that the force of string 2x is equal to the force of string 1. So now what we're going to do is use trigonometric identities to solve for the force of string 2x here. So we'll say that the cosine of 30 degrees is equal to the force of string 2x over the force of string 2. So that would tell us that the force of string 2 is equal to, the force of string 2 x is equal to force of string 2 times cosine of 30 degrees. So that's equal to 100 times the cosine of 30 degrees, which is equal to 86.6 newtons. So we'll put that in here. So a couple things you want to notice here is that, just a little review of what we did here to solve for the forces of string 1 and string 2. So first, looking at the diagram provided, we noticed that it's this problem involves tension forces. So using that, first we had to create a basic force diagram, and then after that we dissected the force of string 2 into xy forces so that we can actually solve for some numerical values. Then we created a triangle and used some trigonometric properties to calculate values. But the main takeaway from this lesson is that if you have an object suspended in motion, some of the forces are equal to each other. Like we said, the force of the Earth is equal to the force of string 2y, and the force of string 2x is equal to the force of string 1 because the object is suspended in motion. So that's really a big part of this lesson. But obviously, tension forces can vary from problem to problem. But in this case, the object was suspended in motion, so that's why we were able to make these two assumptions. So I hope you enjoyed that lesson, and I'm signing out now. Thank you.